Good morning. My name is Omar Casey. I'm the founder and CEO of OQ Technology, a new space startup based in Luxembourg in Europe that is aiming to build a global satellite constellation dedicated for 5G, Internet of Things, and machine-to-machine communication. I have worked in the satellite industry for more than 14 years, especially in the telecommunication satellite sector, at companies like SCS Astra, which is the world's largest geostationary satellite operator. I have also worked as aerospace engineer at the European Space Agency and also the German Aerospace Center. I have graduated from Bremen University in Germany in the field of information communication technology, and also I hold an MBA from Strathclyde Business School in the UK. I will start by presenting the case of satellite Internet of Things and what OQ technology is doing in this field. So I will share for a second my presentation, which I hope is visible to everyone. So what is OQ technology doing? As we know, there is a global problem of connectivity. Today, cellular communication is very limited to about 25% of the Earth's land mass, while the rest of the oceans, mountains, seas, polar regions, deserts lack connectivity due to the limited infrastructure of cellular communication. And what we try to do here is really to extend the coverage of cellular communication. Because of this problem, the only available solution today is traditional satellite communication, and satellites are more expensive than cellular and mobile communication. It costs 2,000 times more to transfer data from a remote area compared to exchanging data in an urban area over the mobile network. And this, of course, affects a lot of industries that operate in remote and rural areas. For example, logistics, consumer IoT in remote areas, construction industry, agriculture, environmental monitoring, security and defense applications, oil and gas and energy applications, maritime, for example, tracking of ships, and also the aviation industry. And today, the opportunity of the satellite Internet of Things and machine-to-machine market is very large. It's estimated that about $12.4 billion will be generated in revenue by 2029 from satellite machine-to-machine communication. So what we are trying to do here. So OQ Technology is really looking to build a global hybrid system that combines both satellite and terrestrial wireless networks to provide connectivity using 5G standards for IoT application. And this actually gives an advantage. As you can see in this figure, traditionally, mobile devices, smart cars, cellular IoT devices are dependent on mobile operators and cellular towers in urban areas to connect. Once these devices move outside the coverage of mobile networks, there is no other way of communication with these assets. And the only way is traditional satellite solutions, which are different from mobile communication technology. What we try to do in our technology is really to build a synchronous system based on 5G technology so that the satellites act as if they are cell towers in the sky. So it's a low Earth orbit constellation of small satellites that collect data and communicate with their mobile IoT devices just the same way that mobile operators with the cell towers communicate with these devices. And hence you can have a seamless handover between these networks anywhere on the Earth. And then the data is relayed back into a 5G compatible core network and then into the internet. And really what we did here in our company is that we tried to develop the 5G software that can be embedded on the payloads of the satellites, but also on the cellular chips, already existing cellular chips, in order to enable them to do both satellite and terrestrial connectivity anywhere in the world. So this, what we use here in order to reduce the cost of the telecommunication service for IoT, which is the main requirement, is to use what we call nano satellites. These are shoebox size satellites at a low Earth orbit. So we're talking 550 to 600 kilometers, covering the whole Earth from North Pole to South Pole. And using these satellites, which are very cheap to build and launch and very quick compared to big geostationary satellites, we can have very low cost connectivity anywhere in the world. The technology we use is based on narrowband IoT, which was standardized in 3GPP in 2017 in release 13. And that technology is really will be used for 5G machine-to-machine communication. And we did test the waveforms for this technology in orbit in 2019 using 2 nanosatellites in our Tiger 1 mission, both for the uplink and downlink. And we confirmed that these can work in low Earth orbit in the desired frequencies that we look for. And we did also patent the system of use of this technology for non-terrestrial networks. We're also looking to launching a satellite where we can have direct 5G IoT connectivity with devices by 2021 in what our MaxSat mission collaboration with the European Space Agency and Luxembourg Space Agency. We have also looking into future developments and build partnerships with other space institutes, for example, the Mohammed bin Rashid Space Center in UAE. So what is really the product and service that we are looking for? So our service is really providing narrowband global area network connectivity. It's reliable and secure end-to-end solution for IoT and M2M global connectivity, compatible both with satellite and with cellular communication anywhere in the world. The device that we offer is actually hybrid cellular and satellite solution that connect both to a cellular network and to our satellite network so that users can have continuous connectivity anywhere they go. It's based also on prepaid data packages. So you can have 1 kilobyte per day, 10 kilobyte per day, 1 megabyte per day, or up to 5 megabyte per day, all prepaid, similar to a mobile network. The service has a lot of advantages. So first, it's interoperable with the mobile networks because it's based on 3GPP standard. It's low cost compared to other solutions. It's low power, so a device with a battery can last for a long period of time, depending on the usage of the user. And you can have high data rate compared to other satellite IoT systems. Also, it's highly scalable, so it can connect millions and millions of devices, and it's highly secure and reliable because it follows the 3GPP standard. So in the end, as you can see in this figure, there are 2 modes of operation, like an aggregator mode, where there's a gateway that collects the data from different sensors using different interfaces, wired and wireless, and then relays this data either to the cellular network or to the satellite network, or using direct communication narrowband IoT to the satellite network. Then the data is downlinked into a ground station network around the world where it goes into the cloud, our cloud, or even the customer's cloud, where it's also compatible with AWS and Azure services. And in the end, this data is received at the customer site and his, her, or her devices. So this is an example of our device prototype. As you see, it's very small, very compact, with the antenna embedded inside and our software inside, which is compatible with narrowband IoT, and it's available for testing with potential customers. So please talk to me if you'd like to start a pilot campaign. Really, what we try to look here, our vision on the long term is to make every smartphone and IoT device speak the same language as satellites. In the end, I'd like to thank you very much. And also you can follow us on LinkedIn, on Twitter, or visit our website to know more details about our product and technology. And I wish the 2021 China Space Conference and the Commercial Space Symposium all success and good luck. Thank you very much.